Question number 2 on exam 3 review. We've got a Ferris wheel. I guess it's me. I'm sitting on a Ferris wheel. Maybe it's not me. Let's change this to blue. There we go. Exactly 35 feet from the center. He is exactly 35 feet from the center and is at the 3 o'clock position when the Ferris wheel begins moving. The bottom of the Ferris wheel is 5 feet above the ground. So let's kind of draw that picture. So the radius must be 35 because that's where he is, 35 feet from the center. Here's our Ferris wheel. We're at the 3 o'clock position. When it starts moving, okay, so we've got a radius here of 35 feet. And the center, the bottom of the Ferris wheel, so not to the center, because the center would go 35 plus another 5 if you wanted to. But the bottom, here's the ground here. This is, this here is 5 feet. This little distance here. So, well, a lot of times what we need is where's the center in relation to the ground. So I'll draw this in. Here's another, that's a 35. So we want to remember that really the center of the Ferris wheel is 40 feet above the ground. Okay, you can kind of see that 5 plus 35. Okay, let's go ahead and start answering some questions. If Michael swept out 150 degrees as the Ferris wheel rotated, how many feet did he travel along the arc? Well, remember our arc formula. So the arc length, that's a distance, is r theta. Theta in this case is in terms of radians. We can't just multiply it by degrees because that would give us a weird an answer in terms of degrees. We want it in terms of distance. Okay, so we first have to convert this 150 degrees into radians, and we do that recognizing that 180 degrees is the same thing as pi. So here's our conversion factor. This is how we go from degrees to radians. Okay, and we can do some reducing. I guess we could just say this is 150 degrees pi 1 times 180 over 180 degrees. So what happens is the degrees, the units of degrees cancel out. So we're going to be left with radians. 150, 180, well, 10 goes into both of those, and 3 goes into both of these. So 3 goes into 15 5 times. 3 goes into 18 6 times. So 5 pi over 6. This is our radian measure. And again, you could, since we're going to want, we'll just go ahead and put this in. You could also do it in terms of a decimal, right? But a decimal is going to get rounded, so this will be more accurate. So the distance, the arc length, is the radius, 35 feet, times theta in radians, 5 pi over 6. So let's just go ahead and multiply that out. 35, let's just kind of put that in there, 5 pi. There's my pi key there. And then we'll divide it by 6. And there we have it. Let me just switch over to red. 91.6296298. And again, how many decimal places do we want to go out? This is in terms of feet. It's certainly, yeah, good enough. Okay, so question 3 will also be in terms of the Ferris wheel. So see, we didn't need quite as much space here. I'm going to take off a line there, and let's kind of move up a little bit. We have to come back. Got our details here, so we'll do that. What angle measure, so suppose Michael traveled 22 feet along the arc. What angle measure in radians has Michael swept out? And then in degrees, so we're going to have to do a conversion here. Just give a little bit more room to work here. Okay, what angle measure? So traveled 22 feet. So we know the arc length. Again, we're going to use this basic formula. But we've gone 22 feet. We know the radius is 35 feet. And we multiply that by the radians, right? And so what we're going to do is divide both sides by 35. So 22 divided by 35, that's what's going to be our theta. The 35 on this side we cancel out. And so we go ahead and do that. So in terms of radians, we get that 0.6286. If we round that up, that's what theta is. And that's in terms of radians. And I was in the wrong, I was looking at the wrong thing. Good, so that, yeah, that's the correct, and we could say radians. Okay. What angle measure is this? Well, let's give a little bit more room here. We have to do a conversion. So we're going to convert our 0.286 or 6286 radians by multiplying by that same conversion factor, but this time pi goes in the denominator because we want to cancel out the radians, pi radians, 180 degrees. Now, yeah, you could use 2 pi and 360 here, whatever you want to use. This is kind of the simplest factor. Okay, so then we end up with 0.6286 times 180. Degrees is what's going to be left. The radians, I'll do that here. You think of as canceling out, all divided by pi, which is just a number now, right? So we can multiply this out, and we can take our answer. That'll make it a little more accurate. We take the answer times 180. And notice all I had to do was hit the time sign. If you wanted, you could copy this down or write it in. And then we divide it by this pi. And this is going to be more accurate than dividing by 3.14 because it's got all the decimals for pi in here. Okay, so that tells us that we've traveled 36.014 degrees. Okay. Determine how many feet above or below the center of the Ferris wheel Michael is after traveling 22 feet along the arc. Well, let's see, 22 feet. It's not a very good looking 3, is it? Okay, let's clean that up a little bit. 36 degrees, right? He started here, so 36 degrees is going to be something like this. So slightly above the center. How do we figure that out? Well, we just need to take how many feet. We want the exact feet above, so that's going to be multiplied by the radius. Feet above is going to be in terms of sine, and we just we know that the angle he has already traveled out. Again, we could use this thing here, but we could do it either in radians or degrees. it just depends on whichever one we use. We have to make sure our calculator is in that mode, right? So we're gonna, I'll just, since we're in radian mode, I'm gonna stick with radians. So we know it went that many radians from, I guess I should maybe box these in, right? That was that answer there. That's the A answer. This is the B answer. And maybe I'll do both, but let's go ahead and just do this first one. And I'll show you, we'll get the same answer as long as we switch modes. 0.6286, or at least, you know, we maybe got slightly different roundings there. So that means 20 feet, 20 and a half feet, right? feet. Yeah, they've got 0.5796. Let's see what happens if we go with the degree. And again, it just depends on, we've got some kind of a rounding issue here. So since I'm going to be in degrees, I'm going to make sure to change my mode over to degree. I'm going to hit enter. Second quit. That brings me back, and notice up here it says I'm in degree mode. Let's see what happens if we do 35 sine of 36.014, which are degrees. Should get relatively close. And we do, but obviously because of rounding errors, whatever, or differences, I'll say, this is what we're matching much closer to what the answer at the given in the solution key. But just to show you that there is a difference, and again, somewhere along the line, radians tend to be, because notice we've got 1, 2, 3, 4 degrees, 4 decimal places on the radians, and I think we did round this 6 was a 5, so it was rounded up. This one we didn't have to round. Maybe if we went one more decimal place out, maybe it would make that difference. But notice in terms of feet, it's still 20 and a half feet. We're off by at the hundredth place. Okay, but that happens. So just, you know, as far as accuracy. Okay, question 3. Finish that one up.